Next electrostatic question. All right. A particle P with a charge of this, it's a positive charge, 1 meters along a straight line from particle V with a positive charge. Right, both in coulomb, distance already in meters. A third particle Q at point X meters away from P, as shown above, experiences a net electrostatic force of 0 Newton. Right, let's look at 7.1. How do the electrostatic force experienced by Q due to the charges on P and V respectively compare with each other? Now, because of this net electrostatic force of 0, we can say that the two forces are equal in magnitude but opposite in direction, because they are in different directions located relatively towards Q. Let's look at 7.3. Calculate the distance x. Now, we've already had a look at the net electrostatic force of Q being 0. Therefore, we know we're going to use the force equation. Right, so we're going to look at the forces between V and Q, as well as between P and Q. Okay, let's start with P and Q. Okay, Q1, Q2 over R squared is equal to 9 times 10 to the power of 9. We are calculating the distance, which is x. Let me just go back there. The distance between P and Q is x. Right. We do not know what Q's value is. Therefore, we're going to work with simultaneous equations. We are going to have a look at least two equations, in other words, between P and Q, as well as Q and V. So we have an unknown capital Q, but P is 5 times 10 to the negative 6. There you go. So that is our first one. Let's look at our next one, between Q and V. Okay, Q1, Q2 over R squared is equal to 9 times 10 to the power of 9. We do not know what Q is. Therefore, we have a second equation. But V is 7 times 10 to the power of negative 6. What is our distance? Let's have a look. It is the total 1 minus the x. And please remember to square it. 1 minus x squared. But we know that the force between P and Q is equal to the force between Q and V. Right? Therefore, we can equal these two forces to each other. So we can equal this force to this force. We will not indicate a negative there because, even though it's opposite direction, because remember, force equations do not have negatives in. Okay, so we're going to say the F of PQ is equal to the F of QV. Let's go. 9 times 10 to the power of 9 times Q times 5 times 10 to the power of negative 6 is equal to, over x squared, is equal to 9 times 10 to the power of 9 times Q times 7 times 10 to the power of negative 6 over 1 minus x, all of it squared. Now let's just quickly look at the algebra part around here. All right, we immediately can cancel these q's out because we have exactly the same on the left and on the right hand side, and both of them is one term on the left and on the right. Okay, what we can do is we can do cross multiplication over an equal sign. we can multiply this denominator with the top there, and we can take all of the values here at the top and go and multiply it at the bottom. Right. And then we can multiply this x squared with a term on the right hand side. Okay, so it's just a little bit of algebra there. And then you can go and solve for x. And x will then be 0.458, always 2 decimals, 0.46 meters.